So this is a black-tipped Caribbean reef shark. They're pretty inquisitive, but they're not like super scary. This kind of looks a little scary just because he looks like he's looking right at me and he's right up in my face. But he's not the big scary shark to be afraid of. I certainly wouldn't free dive with great whites. I did a cage dive with great whites, but not free diving. But beautiful. Sharks are really not. They're predators, but they're cleaners as well. So they're really good for the oceans. They're really not, they have a bad rap. This is up in Alaska. Oh, there's a clownfish. I want to see if I can find that. Okay. This is a bald eagle. Let me grab one more shot, and then I'm just going to get ready to start up here. See if I have the one that was at sun. There it is. This one's one of my favorites. It was about 5:45 a.m., and it just happened to get a nice light over the pack ice and the stellar sea eagles, and just happened to get lucky with that. But you can see how many of these stellar sea eagles that were around. It was total craziness. All right, 10:12. Let me get my demos set up and stuff. I really don't have much to do. I just should probably make sure I'm all set. But yeah, question, comment? We do post, so the question was, do we post some of these on our website? And one of the things that we did, some of you may have noticed when we redesigned our website, is we tied in the theme of immersion with our, passion, which is underwater photography and all the. There's some seats up front, guys. So if you want to be close, you don't need a poncho or anything. I'm usually pretty good. So, but it. Sorry. Maybe I do tell jokes, but they're usually not very good. So, but we tied in a bunch of pictures. And one of the things we did do, if you're interested, if you scroll all the way down, it says website images. And we do have the kind of high resolution version of the images. And then we also describe where and when those shots were taken. This is one of my favorite places in the world. It's actually a subdivision of Raja Ampat in Indonesia, but Indonesia is probably my favorite place in the world to dive. And it's called Mizul, and it was just absolutely stunning. There's Paul. Hold on. See that little tank? Buddy diving at its finest. But anyway, but unbelievably lush reefs and just amazing coral formations in Indonesia. By far, one of my favorite places to dive. So we do have some on the website. We don't have that many. At some point, I'd like to put more out there and actually put some details of what we saw and when we saw it and what we were experiencing, because the stories are actually my favorite part. Like the octopus stories. I could talk for hours about all the wild things I've learned about octopus over the years. So, yeah. It's definitely one of those time things. All right, so 10:14, we're probably going to get ready for our Pass TV as well. So let me just do one last thing with my demos. I don't have a hashtag for the session, but you can use the hashtag Pass TV. And oh, hi, Erin, I was looking for you earlier. And then she appeared. So Pass TV and then Kimberly Tripp. In fact, that's a great point to make. Let me make it at 10:15 so that everybody hears this also for the video. Do I have to shut up for a second and then get ready for the video? Like be professional or something for a second? I can do that, maybe. Let me close this. That looks good. Okay, and that's ready. All right, let's be. Okay, so good morning. Oh, come on, we practiced this. Okay, good morning. Good morning. Okay, excellent. So we're here today to talk about statistics, really. That's one of the favorite topics of mine, really, and it's one that I think a lot of people blame for a lot of problems. I'm actually going to give you some justification and reasoning for that. I'm also going to give you a lot of other things to try and think about than just always updating stats or updating stats more frequently. But that's really the large focus of my session today is statistics and why, when you guys run queries, might you get bad estimations. and I will give you lots of ways to get around that. So I'm going to quickly get into the logistics and slides that I have to do. This is being broadcast on Pass TV, so for those of you that are out here that want to send questions, or even in here if you want to send a question, Erin Stellato is moderating for me, and she's going to check the questions, and if there is a question that's something that I'm either going to talk about later, she'll probably say she's going to get to that, or she might interrupt me and say, hey, Kim, can you clarify X or Y or Z? Just make sure that you put the hashtag PassTV on there, literally all one word, PASS TV, so Erin can see it. And what I will do, depending on the number of tweets that go on Pass TV, I'll try to do a blog post that covers some of the questions that maybe I don't get time to cover. So that will hopefully help you guys after the fact. You'll find a lot of sample code and a lot of demo code here, and I think you guys will really appreciate that. But the point is, there's probably still going to be some lingering questions, and I'll try to get to those on a blog post on the Pass TV. Even better if you can put @KimberlyLTripp, but putting @KimberlyLTripp and Pass TV is now going to make your question like 100 characters, so it makes it even more challenging. But anyway, if you have a cell phone, I don't mind if you leave it on vibrate and say, hold on a second and take it outside, but I would prefer that you don't make a lot of noise. I've got a lot of content to cover. It probably won't distract me much though, so I don't really care. I have a kind of funny slide that the team has been using. Erin actually created this slide, and you can see that Erin created this slide, right? I mean, look at these pictures of the team. My lovely husband, yes, and Jonathan Caius in a sheep suit, and Glenn with his dog, you know. But Erin has this wonderful little headshot, you know, so I kind of made the joke. Guess who made this slide? But Erin is here, so I got to give her some grief. All right, so let me get to the content. Statement execution is more complicated than a lot of people think. I think that there's a lot of confusion out there with how SQL Server works when you run an ad hoc statement. I think there's a lot of confusion out there between what happens with a literal versus a parameter versus a variable in ad hoc, or what happens if we use things like SP-execute SQL, or what happens if we put this code inside of a stored procedure, because when I run the statement by itself, it works really well, but when I put it in a stored procedure, everything goes horribly wrong. And I know you've seen this, right? And you've had these problems where you get inconsistent performance out of things like stored procedures. There are tons of reasons why these things can happen. I'm really going to focus on a few of them around your statements, and then I'm going to focus a lot on VLT, very large tables, skewed data, where you have variations in distribution that SQL Server cannot understand from the limitations in the histogram. So we are going to be studying histograms, we're going to be analyzing histograms, and it's almost comical. In my classes, when I talk about the histogram, I always said, DBCC Show Statistics has this with histogram option. I don't know if you've seen that, so that you can just get the histogram. So then, you should be able to do like insert exec and put it into a table. And I always told my class, so you could actually programmatically analyze the histogram for skew. And I kept saying how easy that would be. So when the Pass Summit came out with its, what are your sessions? I thought, you know what? I'm going to write that code. It's only going to take me a couple hours. Big mistake. Like, as soon as I really started getting into programmatically analyzing a histogram, I realized that that leading column that the histogram covers, right, can be virtually any data type. And if I'm going to then programmatically analyze skew of any data type, I have to generate dynamic strings that are type specific. And what about collations? And what I thought was going to be 3 hours just for my analysis procedure turned into over 20. And I'm really happy I wrote it, and it's going to be really fun. And then I ended up creating a whole bunch of tangential procedures that go along with it. So I think if you feel comfortable with stats by the end of the session, you're going to be able to take this back and even better programmatically analyze your stats and somewhat quickly look at your entire, well, even your entire server if you really want to, and find all of the tables and all of the leading columns that have skew that will be prone to estimation problems. So it's pretty cool. I'm really excited about this. I've never presented this, well, because I wrote it for this session. So I'm really looking forward to this. So we're going to talk about statement execution because we have to understand, when will SQL Server use stats? When does SQL Server sniff a value? That's when it uses the histogram, because there are cases where they won't. So that's what we're going to start with, is statement execution, cost-based optimization, understanding the histogram, distribution skew, and then programmatically analyzing the histogram. We can do that across all of your tables, all of your databases even, and I've got examples for all of that. Then I decided, again, not really my wisest of choices, I decided to see if I could programmatically generate filtered statistics. And that's a little bit challenging as well, but I ended up doing that, and I'll show you how to use that procedure, and that will allow you to better automate filtered stats over time, even as your data changes, which is actually really cool, and I'll show you how that works. Now, there is bad news, because at the end of this, I'm going to tie all that back into statement execution, because filtered objects, both filtered indexes and filtered stats, have limitations in either SP execute SQL or stored procedures. And if you cannot change the application, you might have to do something like a plan guide, or maybe a templatized plan guide. And I'm going to show you how to do all of that. So I want to get started. Let's start with statement execution and kind of go through the simplified concept of this. When you guys execute a statement, SQL Server has to look at it syntactically, because if it doesn't know what it's going to do, how far can it get, right? So it parses. That's obvious. Then they go through a process that virtually no one in here, unless there's somebody from the QP in here, right, that virtually nobody in here cares about, but they take your T-SQL and they do things like they take star and they expand it to the base columns. They take a view and they expand that to the base tables. And they turn that structure into something called a normalized query tree. That query tree is then what they optimize against. And I didn't necessarily mean to put optimization and compilation as this huge part of the plan, but to me, it's the most important part of the plan, right? Or it's the most important part of the entire process, let's say, because this is where you can really have an influence over what the optimizer decides to do. And I'm not talking about hints. Yes, you will have to use hints every now and then, but it's not my go-to. I use it a lot in testing, hints in testing, but I don't want to force SQL Server. I want to try to give them as good of information as I can so that they can do a better job at optimizing my queries. So that's why I really highlighted that. That's what I want to influence. And I also put optimization equals compilation. And that's not necessarily true, but in terms of re-optimizing, the way that you re-optimize something is through compilation. So I want you to think of those as kind of synonymous. If you recompile, you will re-optimize. If you need to re-optimize, then you need to recompile. Recompilation is not always a bad thing. I find that in a lot of development shops, people take the word recompilation and they're like, compiled code is good. And yes, don't get me wrong, compiled code can be fantastic. But compiling a plan that is good for very few executions of that procedure might be worse than recompiling that procedure for each execution. So I just don't want you to think that recompilation is always bad. Sometimes it's warranted. Sometimes it's actually a very good thing to do and to consider. So I really want you to think that. All right. And then, of course, once it has a plan, it'll execute. And that's kind of what's going on when you guys execute a statement against SQL Server. The optimizer uses cost-based optimization. They could have used syntactical optimization. They could have optimized based on the order in which you listed your tables in the from clause. But they don't do that. They could have solely used heuristics-based optimization. They could have done what's called rules-based optimization. And don't get me wrong, if the right statistics don't exist, what else are they going to use other than rules-based optimization? So there are places where SQL kind of falls back on rules-based or heuristics. Some people call them magic numbers, right? They fall back on that, yes, but they really want to do cost-based optimization. They want to look at a reasonable subset of possible plans that they get to or arrive at by looking at things that are in your query. Do you have any search arguments? What is the selectivity of your data? And they want to get some insight into what really is going on. Now, there are things you could do. There are sometimes query rewrites that get better plans. If I look at a distinct join versus an in versus a correlated subquery, an existence test, I often get better results with an existence test. I've taken queries that have ins, and I've rewritten them as union all, and I've actually gotten better results. I'm actually going to show you one of those today with interval subsumption, and I'll define what that is as well. So there are places where a query rewrite might make a huge difference, okay? So I don't want you to think that all queries always process exactly the same way, but largely, it's not about rewriting your query 75 times, okay? That's not usually the case. There are definitely cases, though. Do you have any joins? And sometimes creating derived tables and having a join in the from clause and kind of highlighting a specific set of tables can sometimes help a query optimize better. There are cases. Sometimes even putting a search argument that's more selective higher up in the where clause, very rare, but does actually help in some cases. So do you have search arguments? Are your search arguments isolating one column or isolating a column on one side of the expression? Because as soon as you start to put a computation around a column, you start to eliminate the ability for SQL Server to do seeking operations against it. So there are things you can, my point is, there's a lot of stuff out there that can influence the query plan and can result in poor plans, poor execution times. But that's not what I'm going to focus on in this session. I'm going to focus on data selectivity and join density and making sure that SQL Server really understands at a very basic level how much data your query really has. Because if your query is going to process one row, then the plan to get to that one row is probably very different than a query that's going to process millions of rows. Right? So we need to know that up front, and we need to have good estimates. Because if the optimizer has bad input at the beginning, everything else downstream is likely to not benefit either. Right? So we have lots of potential problems here. We need that to be accurate. So the more information the optimizer has, and the more accurate that information is, the better off we are. So that's what our goal is. How do we give the optimizer really good information? And in my opinion, one of the best ways to influence, not hint, not force, but to influence your queries and your plans is really through statistics. And I'm not doing a session on indexing, but also indexing. So I'm going to focus on stats and what some of the issues are, especially with VLT, very large tables, and VLDB. So let's start with the concept of selectivity and estimations. If I run a query select star from a table, and I've got 3 different potential where clauses, if I'm trying to assess whether or not an index on the column city would be useful, what I have to define is whether or not the data is selective enough to warrant using that index. Okay, that's what I'm trying to do. So looking at these values for a company that is Chicago-based, if our query is select star from employee personal addresses where city equals Chicago, I think we could all probably say that's not going to be a very selective query. That query is probably not selective enough to warrant using the index, okay? Now, if I put where city equals Peoria, it's a few hours outside of Chicago. There might be a couple of reporters that work remotely or somebody works from home, but it's probably a very highly selective subset, so using an index can actually be very beneficial to us. So I would guess there, yeah, this one's probably going to be selective enough. But if I look at a suburb that's just outside of the city, maybe there's even a remote office for this company in Glenview, and there's actually kind of a concentration of employees that live there, then the question I start asking myself is this value selective enough to use the index or not? And this is hard, and you might even say, I think I know my data pretty well and I'm struggling. But we are giving this question to SQL Server every time we run a query, and probably more than once a day. Maybe even more than once a minute. I'm joking, right? You guys are sending sometimes thousands of queries a second to your server. SQL Server has to make good decisions fast. In fact, its goal is not to find the best query plan, it's to find a good plan fast. right? We want to find a good plan fast. So how does SQL Server do this? And the answer to that is statistics is how they do their estimates. So this is my first demo. I've got a lot of code I'm going to show you guys. So let me get in here. So this goes against one of the sample databases that we use a lot called Credit. You might have seen it in some other sessions. And I like one of the tables that I'm going to use here because it has nicely, evenly distributed data. And since all your tables have perfectly evenly distributed data, it's a great table to show you. No, of course, you're here because your data doesn't, evenly distribute across all of your columns all of the time. But if you're new to stats, so this, I would say this is maybe 100, 200 level. If you're new to stats and reading stats, then seeing something that's evenly distributed makes it easier. But I will quickly move to something that's not evenly distributed, and you'll get some better insight there. But I'm going to look at the indexes on my member table. I have a clustered index on member number. I have a couple of other indexes. If you want to get a little bit more internals of the indexes, I have a rewrite to SBLP index that gives you the ID, gives you delimited names, and it actually gives you structures. And the only reason I want to show you this is you can see that I have no included columns in these indexes. I have no filters on any of these indexes. So these indexes literally just have member number, corp no, region number. Those are the only columns. I don't have anything that has last name in it anywhere. So I'm going to write some queries that end up looking at last name. And just to check before we start doing this, are there any statistics? And no, there's no column level stats outside of the statistics that I have on my indexes. So I do not have any statistical information anywhere about last names. That's what I'm trying to show you. So we don't know anything about last names right now. So I'm going to create an index that's on last name, first name, and middle initial, very much like a phone book. And now I'm going to run a query. I'm going to turn my IOs on. I'm going to turn my show plan on. I like keystrokes, so I use the Control-M, but I do have reminders of a lot of this stuff in the scripts as well. And I'm going to run a query here, select star from member where last name is Anderson. So I run this, and I get my rows. Now, what I'm mostly interested in right now is showing you how SQL Server made its decision for its plan. So we'll go over to our execution plan. We'll hover over this. I'll zoom in a bit, and we'll look at two things. What I want to look at here is the estimated number of rows, 385, and the actual number of rows. That looks pretty darn good, right? It's bang on. It knows exactly how much data my query has. So how? How did they know that? It's a great question. So I'm going to go to DBCC show statistics. I'm going to pass in the table name and an index name because that's going to be where it got the statistics. I'll actually show you a little bit later in this session how to put a hint onto your query to output which statistic was used to analyze the query. So you'll see that a little bit later. So I could have thrown that in, but just for right now, I know where this is coming from, so let's look. So when you look at a statistic, there's three pieces here. And you're just going to sound impressive when you say the statistics header, the density vector, and the histogram. Okay, really technical stuff. It's not that big of a deal. It's very cool. I'll show you how to read it. It's so much easier than I think a lot of people think when they look at it. But the histogram is the third one, and very obviously, Anderson has 385 rows that are equal to that value. So the histogram has real, actual values from that leading column of the index. So that was last name, and we know how many rows equal when they generated this statistic. Now, these might not be exact, they may not be perfect, especially if the statistic was not generated through a full scan. So here, you can tell that it was generated by a full scan because the number of rows in the table equals the number of rows that they looked at to generate this statistic. Okay? So this is about as accurate as we're going to get for this data. And okay, we have 385 Andersons, so we've seen kind of how that works. Now, if I run this with another value like Smith, I have no rows that equal Smith, and we go look at the plan, notice the plan is different. It's not a full table scan anymore. And part of that is because the estimate this time was 1, and of course the actual we know is 0. Now, I wouldn't say that's off by a huge amount, although some people would go, it's off by 100%. But my point, let's look at the histogram and see where this came from. If I go in and look at Smith, what we're going to start looking at is where would Smith fall between the steps. So the steps are actual values, and the way you read it is there are 384 rows equal to Ryan. There are 384 rows equal to Stein. There are 0 rows between these values, not including those values. And of those, there are no values. So our estimate, only because data could change, we know it's going to be 1. All right, so that's going to be our estimate, even though you could argue they could do 0 here, but then they could have issues with some of their calculations and so forth. So they just go with 1 to make it simple. My point, look at this data for a second. 385, 385, 385, 385, 385, 384, 384, Yes, it was a loop. It was a loop that just went through and created the rows. But the reason why this is so interesting is let's take the histogram back out and just look again at our density vector. A lot of people don't look at the density vector because they're going to have to do some math. It's not super complicated, especially with a table that has 10,000 rows. But if I take the density times rows, so 0.0384 times rows, I get 384.6. That tells me that the average number of rows returned for a last name is 384.6. Which we can see, since my data is pretty much perfectly evenly distributed, that looks right. So that's what the density vector is telling us. It's telling us averages. So let me go a little bit further with this on where some of these estimates come from. Okay, I've got all the math in here and reminders and notes and all of the scripts to walk you back through every calculation I do. So I put a lot of comments in here. So I think you'll get a lot out of that by looking at this later. So let me change some data because I want to create a little bit more skew, and I want to show you how that starts to affect my stats and how some things are still useful, but other things start to become less useful. So if I update one row and I run a query, okay, I get my one row, and of course, there's my update. But here's the query's execution, and we already know that SQL Server is going to estimate 1 because this is going to fall between steps, and with only one row modified, there's no way SQL Server is going to update the stats. That would become prohibitive. They don't do that. So it's got to have that same estimate of 1, and sure enough it does, and this time, hey, it's right. And if we modify another row, I'm not going to go back to the histogram for that, but you can do that if you want. So I'm going to update another row, and of course, I get 2 rows this time, but SQL Server still only knows, in terms of its estimate, 1. And kind of my point here is if you have an atypical, it might even be typical for you, but an event that causes a particular value, you just launched a new product, and you didn't have any sales of that product yesterday, and today, pretty much all of your sales are that product, that product, that product, that product. You're going to have hundreds of sales coming in where SQL Server is going to say, I don't think there's any rows potentially, and it's going to take a while for them to realize it. In fact, I have a couple of tangential notes here. I'm not going to go into all the automated information, but if you're interested in when stats change, the simple way to think about it is when about 20% of your data changes. But the unfortunate thing for that is if you have 80 million sales and you've just released a new widget, you're not going to know about selling any of those widgets until roughly 16 million widgets have been sold, which is probably too long. So you might want to be updating your stats, especially when they have events like that, more frequently. Okay, that's my key point there. Now there is a trace flag, 2371, which changes the fixed 20% to a dynamic threshold. I've got a link to the white paper. I've got a link to Jürgen's blog post, which kind of introduced this. It's still a trace flag in 2012. It does change things. It turns out I'm not a big fan of letting auto-updating occur anyway. I would much rather you guys manage your statistics through jobs off hours and manage them even more frequently than 20%. And sometimes you'll write code that says, if 2% or 3% of my data is changed, update stats. And you'll do that off hours so that it's not happening at 10 o'clock on a Monday morning when you just started one of these big sales. But there's a couple of tangential notes. Now, in this case, I've updated 2 rows to Tripp. So what I want to know is how that impacts the stats if the stats knew about it. So we'll go back and look at my query, and it'll be interesting because before it used to give me an estimate of 1, and now I go and look at it, and I get an estimate of 2, which is kind of interesting. And of course, my actual is 2 as well. And the reason why it's interesting is when SQL Server generated this histogram, the SQL team, it's amazing some of the stuff that they do and how quickly they do it. But they do try to track interesting values in the histogram. And since there are so few values in my table, it's actually pretty easy to track all of the interesting values in the histogram, because I only had 26 values, and SQL can have up to 200 values in a histogram. So tracking this 27th value is easy. So my point is, sure enough, when I went back and updated the stats, they looked over the entire data set. I did do a full scan, and now Tripp is in there. But the interesting part is, what did that do to my density vector, to my average? Obviously, it affected my average. Before, my average was 384.6, and that's largely what my average is, but then there's this anomaly, Tripp, that brings it down. And so kind of when would this get used, and maybe is this ever an issue, is another question. So let's talk about what happens when you start to run queries in a different way. You might have actually done this, maybe even somewhat accidentally, and maybe even had better performance from doing this. But if you've obscured the ability for the optimizer to optimize looking at an actual value by using a variable, then you have caused SQL Server to use the density vector, not the histogram. Let me be very specific. If I have a variable, last name variable, I set it to Tripp, and I put this variable inside my query, notice when I run this, we know there's 2, we know SQL knows there's 2 when it knows the name is Tripp. The problem here is they don't know the value of that variable until runtime. They have compiled and optimized prior to execution. At the time of execution, they did not know the name Tripp. It was unknown to them. In fact, optimized for unknown is exactly this. Okay? It tells SQL Server, don't use the histogram, use the density vector. And sure enough, my plan is not to use the index because my estimate is not 2. It's 370.37, right? So I'm getting what comes from that density vector. That's a variable. So a variable uses the density vector. A parameter uses the histogram, all right? And I've got a lot more coming up on this, but notes and reminders in here to remind you of this. And you can go back and see the calculations, see where that comes from. Now, another thing that I want to show you, which is really interesting, I'm a big fan of auto-create stats. I'm not a fan of other products that tell you to turn off auto-create stats, but I won't name names. SharePoint. So if I drop the index on member name, okay, so I don't have statistics on name anymore, last name, and I turn off auto-create statistics, not something I'm recommending, and I check to make sure that there's just absolutely nothing that has last name anywhere in it. Okay, you can see the 3 indexes I have. Last name is nowhere in there. There's no included columns. I've got no statistic that has nothing. So I do not know, SQL does not know anything about last names. And I run a query that has a literal, or this could be a parameter as well, in like a stored procedure, for example, and we'll come back to stored procedures at the end. But if I run this, you can actually see what happens is the same thing we just saw a second ago. In fact, the same? No, not the same estimate either. We see the same plan, but where the heck did 1,000 come from? This is a heuristic. There's no statistic. They can't create one. They got nothing. They have to optimize. You gave them a query. They have to run it. They have to come up with a plan. So what do? They guess. And their guess is a fixed internal number of 10% for equality. And it's actually different for less than and greater than and between. And there's all sorts of things that actually change this and influence this. But my point is this is not good. And they actually call it out as well right here. You can see the warnings, column with no statistic. So they're giving you some insight into this, and you'll want to look for this, and you'll probably want to have auto-create stats on. Don't get me wrong, if you're auto-creating stats and then never updating them, that's very bad, okay? And that's part of where some of those recommendations came from. But if you're updating stats, then auto-create can usually be good, but you can also end up with redundant stats, and so you do have to be a little bit careful with this being on. But it often results in better estimations and better query performance than when you turn this off. So that's one of my first recommendations here. And notice with a variable, I get the same thing because it's unknown and there's no stats, so there's no density vector to look at here either. So we get the same estimate, the same warning, the same problem, right? So this is just some insight into where these estimations are coming from and why you may or may not use the histogram. But this is the problem, right? Is the histogram always perfect? And the answer is no, okay? So let's go back. I've got a slide after every demo that highlights all of the key points of that demo, and it'll remind you of some of the things and why you want to go back to the demo. I'm not going to read through every one of these things, but just a couple of points at the very bottom there. These are just estimates. They're not guaranteed to be accurate. They don't have to be 100% accurate to be good or useful, right? Good, plan fast. That's the idea behind these. So where we're at right now, and this is actually exactly where I wanted to be at, which is good, is we've got the understanding of the function of stats. We know when the histogram is going to be used. We know when the density vector is going to be used. But now I'm going to throw in some more complicated stats. And I really want you to understand where in the stats there are some inefficiencies, okay? So the first thing we're going to start with is the statistic histogram itself and where there are limitations in the histogram. So I told you guys that that histogram has actual values in it. It has up to 200 actual distinct values from the table. And even if your table has more than 200 distinct values, they might have fewer than 200 steps. And if that column allows nulls, there'll be one additional step for nulls, so a maximum of 201 steps in a histogram. Okay? What they track, as you saw, was how many rows equal that particular value, and then we start to get some insight into what that step looks like. And that's where things get interesting, because as you start to look at really large tables, right, like partition tables, when you guys start to look at really large tables, if we're trying to describe that entire multi-million, tens of millions of rows table with only 200 steps, averaging the values between those steps, it's going to start to get pretty lossy. The average, when we have lots of skew, starts to not be very good for the skew. So how do we get around that? How do we start to tell SQL Server that there is better information out there, and it just doesn't have access to it? If you have evenly distributed data, you wouldn't be here. And there are columns in your tables that are evenly distributed or reasonably evenly distributed or not heavily skewed, let's say. And if you think about things like sales per order or line items per order, like rows for each order, they might have 3 or 4 rows in that sale. That's probably pretty even. I mean, it would depend on the company, of course. But I'm just kind of giving you something that might be a generalization. But if you start to think about sales per product, like Microsoft products, if I were to look at a histogram for Microsoft products, Office, Bob, right? Huge skew in the products, especially if you look over the entire lifetime of the company, right? So huge skew and thousands of products. I mean, they haven't just had 1 or 2 products. Cinemania. I mean, let's go back in time, right? I mean, hundreds and hundreds and hundreds of products. So the point is, how do we accurately describe sales per product over a really large table if we have 20 years of data in that table? Even if it's partitioned, we can't. We just can't. You think about sales per customer. And you think of all the different types of customers Microsoft has, right? They've got small businesses, they've got individuals, they've got mid-sized business, they've got large companies, they've got government. If all that data, if all those customers are in one database, in one table, that skew is crazy. There's no way. Thousands, tens of, hundreds, millions of customers, billions of sales, right? How do we do that? And you've seen this. You just necessarily didn't know you were seeing this, where the estimates just seemed wrong. And you went, the stats must be wrong. So you updated the stats. And the estimate maybe got better, but it was still just wrong. So then you said, oh, it must be sampling. So then you updated stats with full scan. And the estimate was still wrong. So then you thought, maybe I need to recompile. And you recompile the stored procedure. And maybe that did help, because maybe it had a parameter sniffing problem, and you got better stats, and you just happened to get lucky, and you think you've solved the problem, but you probably really haven't. If it's a very large table with skew, you might have some inefficiencies in the histogram itself. So that's what I want to describe for you, is the histogram, what goes on in it, and why it can be an issue. So this is a much bigger, more interesting table. I've got a version of AdventureWorks that I modified, and all I really did for this particular scenario, if you wanted to do this, is I took the sales key of the fact internet sales table. You'll be seeing I'm using it a lot in my examples. And I just doubled and 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 doubled the table from the original 60,000 rows so that my table has 31 million rows. Okay, so it turns out that the table itself is only about 4 gig, 5 gig of data, but with indexes, I'm about 8 or 9 gig of data. So this is a more reasonable table than the little tables we've been looking at so far. So I'm going to use that. I'm going to turn my statistics IO on, and we're going to look at that later, so I'm going to get that on. And we're going to look at fact internet sales, and we're going to look at the indexes on fact internet sales as well, although I don't need to do this right this second. Oh, I do have to. I didn't even choose the U's. There we go. Nice job there. But anyway, looking at my stats, you can see these are my indexes: ship date, currency key, customer key, due date key, and these are the keys of the stats. It turns out these are actually my indexes. I don't have to do any cleanup here. And I'll run this. I'll talk about the cleanup later, because by the end of this demo, I'll need to clean up. So I look at my stats, and it's the list of my indexes now, because these all have statistics. And I look at these. I have a bunch of like narrow single column indexes. To be honest, this is not the best indexing strategy to begin with. Okay, a bunch of narrow indexes have very few uses. Okay, that's important. But again, I'm not going into indexing strategies so much as trying to highlight a limitation of the histogram. So I'm going to back away from how bad this table really is and kind of focus on just the histogram, all right? You don't want to get me started on that sample database. Lots of great things in it, but that particular one I'm not so fond of. So let's look at the data. This is what's cool. I'm going to look at the customer key and the count of sales, okay? Really simple. And then I'm going to order that by the customer key and who has the highest sales. Okay, so we'll look over my whole data set, and we see that customer 11,185 has 34,000 rows. 11,300 has 34,000. 11,270. Okay, so what do we have? We have 7 customers that are in the 30,000s. We have 8 customers in the 20,000s. We've got another 18 or so, 20, almost 21, that are in the teens, in the 10, 17, right? But we're only 36 customers in out of 18,484, right? So this data actually isn't that heavily skewed, okay? There's a few outliers, but it's not like all over the place. But there's still enough skew here to cause us grief, which is interesting. So let's start looking at what do the statistics know about this data. So if I go and I look at the stats, and I'm going to show you the entire stat really quickly. The stat is old, but my data hasn't changed. Okay, so that's fine. date alone in a vacuum doesn't tell you anything. This was a backup that was restored from a copy that was made then, right? So the data hasn't changed. And in fact, you can tell here, too, that this was based on the entire set of data. So the stats can't get really any better than this. So remember that the all density times rows is the average. So if you do that math in your head, because it's so easy to do, you can tell me what the average number of rows is per customer key. No, that's why I chose that table that had 10,000 rows a few minutes ago. It was because the math was super easy. We can get some insight. If I actually do this math, and I have that a little bit later in my script, we can find out what the average number of rows is per customer. But what does the histogram tell us? So let's dive in and look at specific values. We'll come back to the average in a minute. So let's just zoom into the histogram. And it doesn't matter what value I choose. I think in my demo I use this particular step. So customer 11,142 has 18,000 rows. Customer 11,185 has 34,000 rows, right? That's what this is telling me. And between 142 and 185, but not including those two values, there are 130,000 rows over 42 values. So if you divide 130,000 by 42, you will get 3108.572. So let's be very clear. What this means is if I run a query with 11,142, the estimate will be 18,432. If I run a query that says where customer equals 11,185, I will get an estimate of 34,816. But if I run a value of 143, 144, 145, all the way up to 184, no matter what the value is, every single one of those will estimate 3,108.572. Okay, that's what SQL Server is going to know about this data. So let's check it. 3108.572, something like that. So we'll run a value, oh, sorry, I'm using a different 230. Is that in there? Nope, 230. Let's grab that one. Doesn't matter. Okay, 3954. Okay, we get this. Let's turn on show plan. And we get, phew, a little nervous there, right? 3954. I'm just kidding. You guys are no fun. Okay, so 3954. But that's not right. This particular value has 2560. So we'll go a little bit further. You can see the average. By the way, there's that average. The average overall is 1673. It is kind of interesting when you go back and look at the histogram, just the histogram, you can see that they're kind of clever in that the averages for these steps and the way that they step through the data is maybe giving them information that that step is above average, right? Whereas some of the later steps might be below average, right? So that it's better than the overall average, don't get me wrong. The steps average is probably a lot better in some cases than the overall average. It's a big it depends, because it depends on how skewed your data really is. Okay, so let's come back and drill into that specific step that I was talking about, the 11,142 to 11,185. We talked about this already. We saw what it shows. And here's the point that I want to make. Let's look at it specifically. Let's look at exactly those values between 142 and 145, and let's see what they look like. Let's see what that skew is, right? Okay. So customer 11,176 has 30,000 rows. And at the other end of the spectrum, customer 11,152 has only 512. So the average is kind of off here, right? I mean, is it really going to affect query performance? It depends. There's a lot of factors. But at this end, maybe, right? If it's off by a factor of 8 or 9 times, and in a table that has much more, many more rows and more skew, this could actually be a huge difference and actually make a big difference on your queries. And I'll show you actually that it does make a difference here. If I put in that 1152 and the 11176 and I run the queries, I can see this first one shows me the estimate that we expected from that first one, 3108.57. But the actual, we know this is at the low end, is 512. And this one down here has an estimate of 3,108, exactly what we expected, but it's 30,000. Now what's interesting is, it tells me that the plans are 50-50. The plans are exactly the same. Let's be very clear here. An actual plan is absolutely identical to an estimated plan, with the exception, or with the addition, of these actual, let me zoom in again, with these actual values. That's what you get when you ask for actual plan. You get the estimated plan with what really happened. And that starts to tell you where you might have skew, where maybe something went wrong in that set. It could be that the stats are out of date. It could be that all you need to do is update the stats. It could be that all you need to do is update stats with full scan. Those are things you can try, but when you start to detect skew, those things aren't going to work anymore. You're going to have to go to the next step I'm going to show you. Okay? So you might think, I see skew in this step. So there is the ability, a lot of people know about filtered indexes, but I don't want you to create more indexes here. I don't want you to have the additional structure, the cost of the structure, the maintenance of the structure, the inserting, the updating, deleting of that structure. I don't want you to have all that extra cost. I want you instead to think about what SQL Server needs to know about this data to better use the indexes that you have. And that's the statistics. So you could take this skewed step and create a statistic just for it. You could do that. So I'm going to say, create just a statistic on the customer key for the customer key range between 142 and 185. So I can go ahead and do that. Now, if I look at this particular statistic, let's see if we get better information about 152 and 176. I just wanted to make sure we look for the rows that we're kind of the most interested in right now. So 11152 and 11176. So let's zoom into our histogram and look at 11152. That's interesting. And 11176. Okay, do you guys remember the numbers? 11152 had 512. This is saying 1. And 11176 had 30,720, I think, and this says 31,000. So this one seems a lot better, but this one seems a little bit goofy, right? It just doesn't seem quite right. And you might wonder why that happened. And it was because when this particular data set was generated, they only sampled a small subset of data. This is a case where the sampled set won't yield as good of a statistic as a full scan. So I'm going to show you that. But overall, many of these things will be a lot better. Now, I need to make sure I don't get a textual plan match. So I'm going to make sure that I get a new plan by doing a recompile. I'm going to run the 11172, so I'll first recompile, and then I will run the 11172 at 152 and the 11176. I'm just looking to see if there's anything else in the query. Something looks, oh no, I've got that line highlighted. Okay, so we look and we see 50-50, right? We see our estimate here of, did I actually, hold on. What's wrong with this picture? Did I actually run this? Did run that. And I did run that. And I run this. I'm intrigued. Hold on one second. I'm very intrigued. Oh, I'm a moron. Kimberly didn't clean up something from one of my other demos. Sorry. That's a topic we'll be talking about momentarily. And I think that was on. I hope that was on, because now I'm intrigued. And if this doesn't work, oh, phew, my goodness. So yes, sorry, sloppy demo. Okay, but I look at this, and thank goodness, my estimated number of rows is 1, and I've got 512. But now you can start to see where that's going to come into play, something called forced parameterization. And I told you that using, and the other one, 11176, let's look at that really quick. Look at the plans, though. You guys see that the plans are different as well? I'm not getting the same plan anymore because my estimates are more accurate. This one knows that there's more than the 3,108 rows. We have 31,000, and here's 30,720, right? So we can see that they've got a better estimate, and we've got parallelism being used in this query, even though they didn't need it in this one. Although this one's still off. And like I said, if I created this statistic with full scan, right? If I created this statistic with full scan and we recompile, let's just look at the estimate, because we'll know if the estimate's not 1, that we got a better value. And sure enough, it's not 0 anymore, first of all. If I look here, my estimate is 512. My actual is 512. So this is spot on. And check this one out. This one is still the same plan we saw a second ago, but even this estimate is absolutely perfect. So what I've got with a filtered stat is a smaller statistic, a more accurate statistic, a statistic that's focused on a subset of data, so SQL Server can get a much better, much more accurate estimate out of it. And when your data is heavily skewed, this is really, really important. So when you have a lot of large tables and heavily skewed data, you really need to consider looking at filtered stats. So this is where it actually got kind of funny. When I was in my classes, I would tell people, you know, this is easy. You can go and look at this data. You can get some insight. Famous last words. So my demo showed you this, right? My demo showed you skew. My data is not even that skewed, okay? But I showed you that I can have some issues with my estimates unless I have a statistic that's more tailored, right? And this is what I used to tell people. You can programmatically analyze your histograms to start determining if there's skew across your tables. And I remember thinking, this is only going to take me a couple hours to write. It should be really easy to programmatically analyze skew. And when I really started to dive into it, the one thing that got me the most was the range high key. Remember the high order element of the index, that first column, the leading column of the index? That is what we have actual values. So we saw actual customer keys, right? But what if the leading column of your index is on a GUID? What if the leading column of your index is on a varchar? What if the leading column of your index is on a date time 2 with a precision of 4? I have to deal with that. I have to put that data into a temp table, but then I have to programmatically get those values and start to compare them against the actual values of the table, and I need to do it efficiently, so I don't want to have implicit conversions and table scans all over the place. I have to have exact, accurate data types in all my code. This is a labyrinth of dynamic string execution and exceptions left and right of collations. And did you know, because I didn't know this, 23 years with SQL Server, and I have never run across the fact that in a tables creation statement, the way that collation is listed with the data type is different than when you use it in a cast or a conversion. So then I had to have exceptions of if I need the data type definition for a table, it's a column definition, or if I need the data type for a cast or a convert, it looks like this. So the code started just getting uglier and uglier and uglier the more that I worked on it. But I'm glad to say that I finally did finish it, and I'm actually quite pleased with it. I came up with what I'm calling SP SQL Skills Analyze Column Skew. Obviously, you can change the names of this stuff, but I wanted to make sure it was unique. I do make it so it's an SP underscore, so it can run in any user database, but it lives in master. Obviously, for some of you, this might create an issue in terms of your ability to create system procedures in production. I'm not wanting you to put all my V1 code into production this weekend, okay? Just to be clear, all right? This is dev and test. I want you to use this to play with and understand better what your statistics look like and help you to determine skew so that you can create better filtered stats. Yes, but I do want you to use this with a grain of salt. I wrote this for this session. This code, I'm actually really pleased with. You should have seen me at certain times of day and the colorful expressions I was using. Paul can definitely attest to that. So it was quite a bit of fun, and I really enjoyed it. I learned a ton of interesting things. I'd even recommend that you guys do it. You know, sometimes sit down and look at something and just say, I wonder if I can programmatically analyze that. And it's really interesting what you learn as you're writing dynamic strings and learning how this works. So if I have some time at the end of the session, maybe I'll dive into that code and show you a little bit more of that, but I just want to show you how to use it, okay? Instead of living through the pain again of that code. So here's what it does, okay? My analyzed column skew, I think that font is large enough for right now, but analyze column skew has a bunch of parameters. The key ones are kind of at the top. What schema, object, and column do we want to analyze the skew for? Right? So like DBO, fact internet sales, customer key. That's what we know is skewed right now. So if I want to zoom in and try to find this skew, what am I going to look for? And then I've got the parameters of what you want to look for. So for example, you might want to look for a difference between the average and the min and max values in that step. Right? So remember, that's what I did. I kind of looked at a step and I said, show me high to low. We kind of looked at it as the count descending. And I said, okay, what's that skew, right? How off are we? And if I say you need to have a difference of more than 1,000 rows, then we either have to have a value that's at least 1,000 higher or a value that's at least 1,000 lower. It doesn't have to have both, it just has to have at least one of those. Well, if you say that the number of steps is 1, so then only one step would have to have that difference, okay? I can also, so by default, I look for over 1,000 in at least 10 steps, okay? Now you can also say, I want to see if there's any steps that are off by a multiple, right? Because a smaller value might not be off by 1,000, but it might still be off by 10 times or 100 times for that matter. So you can look for difference or factor or put them both in as a requirement. And I've got examples to show you both of those. You can also say instead of number of steps, the percentage of the steps that have to meet that criteria. Because you might not always have 200 steps, so 10% might be 20, but it might not be. So you might say a minimum of 10, and maybe even a minimum of 10%, kind of whichever one is the more restrictive. And then the temp table that I build to analyze the data, I throw it away if I don't detect skew based on these parameters. But if I detect skew based on these parameters, I keep the table around and I output that name for you, and I'll show you how to use that so that you can go and analyze the skew as well from my already analyzed set. So you can kind of see the results of the skew. And I do keep the table when there's skew, and I also have some procedures to help you quickly clean up all that stuff. I ended up creating like 5 or 6 procedures to do all of this. And I didn't end up using this. I did put it in, and it is coded, but if you end up wanting to call this from something else, and you want to programmatically analyze the tables that have skew, I actually output the table name as an output parameter so that you can programmatically use this. So I kind of made it extensible, but I don't have code to show you that because I'm not using it anywhere except manually. So let me show you this. This is my favorite one. Well, no, maybe the next one. But So the things you need to set up, I put at the very top, the SP Analyze Column Skew. So these are down here in my SQL Skills procs. So I'll show you. You need the Analyze Skew, and it's listed right there, and you'll end up needing the Drop All Column Stats and the Analyze All Leading Columns, and then the demo I'm going to do later is going to end up using these guys. Okay, so you'll end up kind of playing around with all of these things eventually, or some combination thereof. But I'm going to go to AdventureWorks again. This time I'm going to remember to do the use statement. And I could just supply schema object column and not say anything else and just let all the defaults kick in. And to remind you, that was a difference of at least 1,000 for at least 10% or 10 steps, whichever one is kind of the bigger requirement, right? And a factor of at least 1.5 for that same criteria. You probably won't be supplying all of these all the time. But if I run this, you can see that it goes and analyzes my table, and I have a little bit of output here to show you kind of what's going on. Begin processing, so I tell you which table I'm processing. Then I show you column customer key has 163 rows out of 164. So this is steps of the histogram. So 163 of the 164 steps have a greater difference than 100, or 1,000 in this case. So this means there are 163 steps that will result in row estimations that are off by more than 1,000. So just looking at step differences, we are 99% skewed. My query requested a minimum of 10. We obviously met that. And as a result, the table shows skew. You need to consider filtered statistics to help your cardinality estimation. I tried to give useful error messages. I was actually considering putting contact your system administrator just to mess with you guys, but I decided not to, all right? So thought I would be a little nice, all right. So I'm trying to give you some really good insight into what's going on here. Now you might think, well, 1,000 isn't enough for me to actually be worried about this. So you might want to run a few different parameters. And by the way, I have a huge number of notes in here that's going to tell you exactly what all these things mean. And the larger the table, the more skew, the higher you might want the values to be, blah, 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 blah. I'm just as verbose in my code, okay? So there you go. So now, here's another scenario where I might say, you know what, I only want to see if there's steps that have 20,000 as a difference. Like a much larger amount of skew. And in some of your tables, you might say, I want to see 100,000. And you might not get many steps at all. But notice I'm really limiting everything else. I'm just saying, I'm not going to look for factor. I'm not going to look for a percentage. I just want to see if there's at least one step that has a bigger skew than 20,000 rows. Right? So I run this. Now, it is having to go to my indexes to do this. I only will do this when there are indexes to support my analysis. So it's not that expensive to do, but it will end up requiring that index to go into cache. So this table is only 4 gig. It's taking 2 seconds on my machine. I'm not saying that that's going to scale because hardware is obviously a factor, but it is true that bigger tables with bigger indexes might require more memory and more time. So again, test environment, test environment, test environment to get used to this, okay? To make sure that you really feel comfortable with this. But it's not going to do like 164 table scans, which if I didn't have an index and if I didn't write my code right, it could have potentially done that. So I really worked hard to try to make this as optimal as I could. But look what happened here. I actually have 7 steps, right, that have a difference greater than 20,000. So that means that there are 7 steps that are going to yield row estimations that are off by more than 20,000. And again, this is starting to tell me that I have skew. So we know that. I mean, we know that, but now you might think, okay, what if I want to check for 6 times in terms of a factor, right? Are there any that are 6 times higher than the estimate? So like if the estimate is 2,000, we're looking for something that's 12,000 or more, right? And sure enough, we can see in this case, right, it's 7 as well, that has more than a factor of 6. So you can start to get some insight by different values that you're looking for. Here, I'm now saying 10 times, okay? And I'm going to kind of skip a few of these things and get to this part, which is, what if you want to really see that data? Like you're thinking, it's told me I have skew, but I really want to see what she was looking at, right? And if you noticed my message, because I kind of didn't show you all of it, this one comes from SQL Server because I do a rename on the table in TempDB if I'm keeping it, because I use kind of a generic name when I'm coding, but if I find skew, I put it into a name that's very descriptive. And that name, I show you even here, right? I said we, I don't know who we is, but anyway, we saved the table as, and you can literally just copy it here. It's a really ugly long table name, but the reason I did that is you can see I grabbed a subset, well, I grabbed a little header there basically, or a prefix I should say, and then I grabbed a subset of the database name, especially for a long database name, the schema, the object, and the column. So it's very descriptive. So you'll know exactly where these temp tables came from. And then if we look at that temp table, you can see I've got the steps, I've got the averages, and then what I've kept track of is the minimum and the maximum within each one of these steps. So like between 1178 and 11106, the average is 4058, but there is at least one row that has a minimum of 2048, and there's at least one row with a maximum of 30,208. So the biggest difference between the 4,000 and the 30,000 is 26,000, right? And that difference results in a skew of 6.44 times. Right? So you can start to see what I analyzed. And now you can start to see where all your issues are. You can even see that a lot of our issues are in the earlier part of the table, which makes sense, right? The older customers have hopefully bought more, right? So they're more skewed over time. But we're starting to get some insight into the fact that this VLT, this very large table, has skew. And instead of just having one filtered stat for one particular step, maybe I need more than that, right? Maybe I need to actually have more than this. And by the way, I'm a 90-minute session, just so you guys know, and I will be using 90 minutes of it. So, all right. So, if you're like me, you're probably thinking, do I really have to do this column by column, table by table? Please tell me she's not going to make me do this. No, because I'm just as lazy as you as a developer, and I said, oh my God, I've got to make this easier for me to test it, right? I wanted to test it faster. So I ended up creating a procedure that's called analyze all leading index columns for skew, right? So in other words, I want to use indexes to make this efficient, so I'm going to go out and analyze every single leading column that you have. Now, in this case, I made it so that you just supply a table, and then you set the values you're interested in, and we'll run it across the entire table for all columns that are leading columns of indexes. Okay, so only those, and I think I had 8 or 9 indexes on this table, so it's going to take a little bit longer to run. It's going to have to put this data into cache, so you're going to have to be aware of this. This is one of those, you know, nice coffee breaks that you can go and on a bigger table. It might take a few minutes to actually run. So it took 20 seconds for me on my machine, and sure enough, if we look at this, the column, it's a little bit wide. Currency key doesn't seem to show any skew based on these parameters, right, based on what I supplied. But customer key does, due date, order date does, order date shows skew, okay? So we're starting to see that there's a couple that show skew based on what I just passed in, but not too many, okay? Because this was more than 10,000, you know, more than 10,000. I can go start to look at the tables, the work tables that I created, or I could maybe lower this to see if maybe 5,000 generates skew. But my point is you can play around with this. It turns out there's actually 4 columns that have a skew of more than 5,000. So that's possibly interesting for you. It depends heavily on whether or not that affects your queries, which I can't answer, okay? But that's interesting. And of course, that was too slow for me as well. Okay, so I got a little annoyed with that. So I made it so that you didn't have to supply a schema or an object, and I'll go and I'll check every single leading column of every table of that database. So hold on, let's get this running. So I run this and I'm looking for a difference of more than 2,000. So I'm basically just saying, show me across every table whether or not you find any columns that have any skew defined by more than 2,000 rows between the average and the actual for at least one step. Okay, and again, it turns out to be 8 that have this. For the 8, I can then take those tables and I can start to look at them and see exactly what they look like. And I'll come from that and say, okay, I've got these 2 or 3 columns that show significant skew, and you correlate that with the fact that these queries are not working correctly for you. You already know you kind of have a problem here. You're here because your queries aren't estimating correctly. You've tried updating stats. You've tried updating stats with full scan. It's not working. It's because they cannot get any better with the limitation of 200 steps. So sure enough, this just went across my whole database. It took 49 seconds. My database is about 20 gig, okay? And I have a pretty decent machine, so this could take some time. I mean, if you're going to run it the whole database, then, go to lunch or run it over the weekend or whatever. So you can see it kind of scrolling quickly. Most don't have skew. A lot of the dimensional tables are too small to really be skewed anyway, right? But as we start to get to some of the bigger tables, and of course, fact internet sales is a recurring theme in here. There's a different version of fact internet sales, but again, it's a large table. And it shows some skew as well. And if we go a little bit further, what else do we have? Fact internet sales. There's fact internet reseller sales, I think, has some skew in one of these databases. But the point is, you can go and start looking for this and start to see which columns to really analyze. And of course, that was even too much for me. You could do this. You don't even have to pass in any parameters. And is Aaron here? No, Big Aaron. Aaron Bertrand, is he here? Sorry, we've got sorry. There's a little bit of insight into the Paul and Kimberly world. Big Aaron and Little Aaron. Little Aaron is E-R-I-N, Big Aaron is A-A-R-O-N, and that's how we refer to you guys. So there you go. Is he in here, though? No, he's not even going to admit he's in here if he's in here. All right, but I'll come back to this management in a second. I showed SPMS for each database, and I was going to do this because Aaron hates this, because it has all sorts of issues. I totally agree with him. And I say, no, just kidding. And then he's got a blog post on a better version, and it's called SP for each DB. So if you guys want to run something across all of your database, let me run this. I forget how long, it takes about a minute on my machine, which, again, the only database that's big is the one I'm in right now. So all the other databases it runs pretty quickly in. But you can see that I'm actually running it for all user databases across my entire server, and with the criteria that I defined as the defaults. But you could put in the other criteria if you wanted here. And so we'll let this run. Like I said, it'll take about a minute. And when it comes back, we can look and see that there's, again, just those 8 or so that show skew. What I also did, because again, I'm really lazy, if you end up having 8 that have skew and you want to look at those tables, I got really lazy copying and pasting the table names. So I wrote a little procedure that shows me the queries that I need for all of the tables that are currently in TempDB, which are all of the tables that showed skew. So if I say SP SQL Skills histogram temp tables query, it'll give me all the selects for all the tables that have skew that are in TempDB. And if I finally am done, since those tables won't get deleted, I need to drop them, which was the other way to run this. But this is my whole server now. I just did my whole server, and I can see that I have skew in very few places, but again, it's the larger tables that are going to have skew. And it's, again, the tables we've been seeing. So I'm not going to spend any time here. And let me just show you the query. So for everything that showed skew, in fact, you might even argue this is better, because you can skip all the ones that didn't show skew and do this. These are all the ones that showed skew. Which ones? Well, AdventureWorks DW, modified sales key, fact internet sales 2, order date key. AdventureWorks DW Denali, fact internet sales reason, sales order number, right? So these are, from the entire server now, all of the ones that showed skew. Sorry, Aaron, I know there's somebody that has a question. And I can literally paste this in and start walking these to understand my data. See, This is the benefit of having a developer who's lazy write your code, because they always want to write more to automate it, right? And in fact, that's where I'm going to go next. We know we have skewed data, right? And let's drop these, okay? So I'll just show you the end result here. We'll drop these. And I didn't actually drop them. I generated the code to drop them. If you guys want me to, I can write that to do the loop to actually drop them. But I just wrote it so that it would generate it. It was a lot quicker than cursoring through, but I dropped them. Okay, so now I have nothing in there, and we're done with this one. Aaron. So yeah, this is a great question. So why did I choose factor and not things like standard deviation, mode, median, mean? SQL Server doesn't have all of those functions to begin with. You could easily put in standard deviation as a function instead. I wanted something that was really visual and something that was very easy to describe, so I kind of kept it simple. But you could, I actually was going to put standard deviation on the end of it and do that as another one. And I kind of thought, I'm already like 25 hours into coding my free V1, and I thought, I'm giving you the code so you guys can put in standard deviation, mode, mean. So there are lots of other things you could do here, but totally. And SQL does have standard deviation, so I could have done that, and variance. I kind of wanted to keep it simple, but you could totally add all of that. It's a great question. It's a great question. So, okay, so where are we at? Let's go back to my slides for a second. Not every table has skew, clearly, right? Most of my tables didn't have skew. But we probably already had our suspicions. Now we've confirmed it. We've actually seen how many steps have skew. And it's a lot more than just that 11,142 to 11,185, right? Really, 163 of the steps showed skew based on the parameters I was looking at. So we need to think about something that's going to work for us longer term, especially as this data changes. And my last thing down here, just to remind you of, don't forget to clean up those temp tables. I did put them in tempdb, so they will eventually get cleaned up, and they're not very big. They only have like 200 rows each, right? So they're not huge tables. They're not going to like blow up your tempdb or anything. But just make sure you clean up after these tables, because I do keep them around when there's skew, and you'll have to drop them. But I didn't put them in your user databases at least, okay? Now, you think we've got skew. And I used to say this in my classes too. And I think back to it. Sometimes I look at it and I'm like, automating the creation of filtered stats really wouldn't be so bad, right? But the questions are, how do we break down the data, right? And how do we account for new rows as new rows come in? Because customer keys aren't just a static value from 1 to 18,484. We have new customers. We have new customers every day, right? So how do we account for that? And how do we maintain this over time? Because obviously the data is going to change. So I used to tell people, it's easy, okay? Until I wrote the code. Conceptually, it's easy, right? It's easy because all you have to do is take this sales table, this one big, large table, and take it in chunks. Right? We've got 20,000 customers, essentially. So what if we were to create a filtered stat that goes over just the customer range 1 to 2,000? And then we go ahead and we do the same thing for all of the other sets. We go 2,001 to 4,000, 4,001 to 6,000, and we end up creating 10 stats over our entire set. This is fantastic. And because every one of your statistic column is over an ever-increasing integer with no gaps, you'll have no problem doing. That's the point, right? It's not this simple. You're going to have gaps. You're not necessarily going to have an ever-increasing numeric. If there are rows coming in and the data is changing, how are you going to deal with that nth value beyond the set that you're in? And how do you even pick the values? How do I just divvy up a table into 20 chunks, especially when there's gaps? And then I thought, I use the same table I just used to analyze the stats. I take the steps, which are actual values, and I divvy the steps up, and I generate my filtered stats off of the histogram. And that's what I did. So I created an SP SQL skills create filtered stats with a bunch of parameters that I'll show you, and it requires these other procedures. That's right, Aaron has to leave us, but I'm not going to call you out or anything. So it requires 2 other procedures: create filtered stats string and drop all column stats. One of the things that is redundant when you start to create the filtered stats are any column stats that are on that column before you create the filter stats. They're redundant now. So I'm going to drop any column level stat that's just this column, and I will also create new filtered stats to replace it, and I have to do that with an ugly string. So I pulled the string into a separate procedure. You can look at that. So here's the end result of my filtered stats. Again, we have our schema object column, recurring theme throughout all my code. And then you set parameters as to how many filtered stats, whether or not it's an ever-increasing key, what is the actual maximum you want to project for. We can calculate this, but this you will have to probably calculate yourself, which probably won't be difficult depending on what the data is. Okay, so that's probably the only issue. But having said that, this is still significantly easier than you guys doing all of this yourself. And it's way easier to automate, and I'll show you that. And then, do you want the stats to be generated on a full scan, or do you want them to use sampling? And if you choose sampling, what percentage do you want to use? So I tried to make this really flexible and put in all the options that you would possibly want for this. So let me go over here, show you my filtered stats. Okay. You need all of these scripts. I'm going to go to AdventureWorks. I'm going to check my stats and my indexes. And the one thing I want to remind you that I do have right now is that one stat we created a little while ago over that one step that was skewed, right? That's going to get dropped. We don't need that anymore because we're going to supersede that with better filtered stats. So that's what I was talking about. This one's going to become redundant. So I'll clean up any of the stuff that might have been there from other processes or whatever. And they might even just be redundant. So now, I've got a bunch of notes again in here. So what I do here, since customer key is an ever-increasing value, then what I'm going to do is I'm going to set my max to be whatever the max is right now plus however many days I'm going to let this filtered stat stick around for before I end up redistributing my data again, which is going to be just like an update of stats, but you're actually going to drop and recreate. And the reason why you're going to drop and recreate is because over the course of a week, you might get 10,000 more customers. So we're going to need to redistribute our stats and maybe even increase the number of stats. Maybe you'll even start with 20 stats instead of 10. But still, 10 is 10 times the number of stats you have now, right? So you're going to have 10, essentially, stats that step through the data 10 times what you were doing before. So this, even at 10, is probably much more accurate than you have. So for fact internet sales customer key, I'm going to step through, create 10 filtered stats. It turns out that 10 actually means up to 12. And part of that is because I take the 164 steps, divide it by 10, and what do I get? 16.4. I can't step 16.4 through the histogram, right? So I take the floor of that, so I step 16, which is going to get me a few from the end. So I step at least 10, then I have to step an 11th, and then I have to step your max. So you actually will get 12 here. Not a big deal, okay? We're trying to get better stats anyway. I'm just trying to tell you that you might put in 10 and you might end up with 12 or 11. That's fine. Look at the values and you'll see exactly what it's doing. So I'm gonna run this. Oh my God, this just makes your life so much easier. And this is, all it has to do is generate the data set. So give it a few seconds here. Okay, it created. And what do we have? Remember, we had one filtered stat when we started. We don't need the indexes, actually. Let's just do the stats. And now what do we have? We have a filtered stat that goes from 11,000 to 11,566, one that goes 566 to 12,461, 461 to 13,6. And these are the actual first 10. Here's that last blip that gets us to our max value. It was fun flipping back around in cursors, fetch first, fetch relative, fetch last. Hadn't done that for a while. And then 29,483 to 30,000, right? So there's my n number of rows for the number of days I'm projecting out for, which is, I'm sorry, I'm very proud of myself on this. This is wicked cool. I'm so happy that it's so much easier because this is something I've done manually, right? Has anyone done this manually? No, thanks you guys, thanks. It's awesome. So I'm very happy about this. So SP recompile, and I'm gonna run, here's my query trace flags to get some insight into what they're using. So I'm gonna recompile against factor and sales. I don't have a plan and cache for this, but I'm still gonna do it. And so we'll recompile just to make sure there's no textual matching. I'll run this. I get my data. Let's turn on show plan as well. And we, first of all, go over here. This is good to see. Okay, the estimate and the actual look great. And if I go over here and I look at, I ran it twice. Sorry. You only get, I got a textual match on the second execution. Remember, I ran it and I said, let me turn on show plan. I turned on show plan, I ran it again. I got a textual match. It didn't load stats because it had already loaded the stats, right? Because it used the plan that was there. So that's why. So let me just recompile so you see the results. So you can see that didn't change. But there you go. So the filtered stat that got loaded was the one that covers this particular step. And you can see the expression. Okay? So that's pretty cool. And if I go through all of these, you can see that I'm getting, estimates and actuals that maybe are better. I think I've got one that's not. And I think this is one of the points that I wanted to make. Yeah, like that one is good. You can see the 3720. And this one might be the one that's off. Yeah, this one's off a little bit. Do you see this? 1728, 512. And it was because my default uses sampling. So I told you that sampling's not perfect. So it could be that I either don't have enough stats or I want to do full scan. Okay? So depending on the size of the table, maybe we'll bump it up to 20. And notice I'm doing 7 days at 100 new customers a day over the max. That's the idea here. So I run it this time, and all those other stats get cleaned up. I kind of needed to do that. So there we go. And I'll run this, and you can see all those other ones are gone. And we've just redistributed 11,000 to 277, 277 to 566, 560, and so forth. Okay? So this is now our filtered sets. Do a recompile, run our queries, and it was the third one. It was only the third one that was off. So like this one, I'm just going to show the one that's off, so I'm not going to spend any time zooming in until I get to the one that's off, or was off. This is the one that was off. And notice now we've got the 512 and the 512 this time, and the fourth one down here. So the cool thing is SQL Server is a lot better able to know how much data. It's choosing the parallel plan when there's more rows, whereas when it was getting those averages, it wasn't hitting that parallelism threshold. Or even more interesting, some of you might have estimates that are kind of high, and you're getting high memory grants, or you're hitting resource governor thresholds and having problems. There's all sorts of problems from these estimates being off. I've still got 3 minutes, okay? So 10 to 20 should be enough for most tables, okay? And if you want to quickly drop all the stats, you can do that. And I've got all the code to do all that and a few final notes. So this is cool. I'm good. And these are just notes on my demo. All right, so a couple of problems. My last couple of minutes, I want to do a couple of problems. I'm probably going to need like 1 or 2 extra minutes here. But the last couple of problems are that, okay, filtered stats might not always work. And there's one big problem, it's called interval subsumption. But to be honest, interval subsumption is actually not as big of a problem as you might think. Interval subsumption is very simply this. If you've got a predicate, actually I've got a slide. If you've got a predicate that crosses a filtered object's defined boundary, such that you'd need to use 2 filtered objects, SQL Server says, nope. That interval is not a subset of my filter predicate, I'm not going to use it. Full stop. So there are sometimes ways to rewrite queries, but for range-based queries like dates, if you've got a filter for January and a filter for February, and then you say you want January 15th to February 15th, no dice, okay? But as you start to go January 15th to February 15th, Do you care that every single value is accurate anymore? Isn't the average over that set gonna average out? You don't care. So my point is interval subsumption is not as big of a deal unless you're looking at, or I should say this problem is not as big of a deal because average will work. The problem that we were trying to solve, point queries, we are solving. So I'm not as concerned about this except in one case, and that's in. In is annoying. I'm going to go through this quickly, okay? We already know what we've got, so we're not going to review our stats. So look at this query. These 1153, 11152, and 11222 are all within a single filtered set. So this, turn on show plan, run it. If I look at my estimate, now hold on. I have 3 values, so estimate times rows in terms of executions. So 1536 times 3, 4500 plus 36 times 3, 108 is 4608. Perfect, no problem. And since I said, didn't I? Yep. Since I said, show me the filtered stats, you can see it use the filtered stats. Okay, so that's great. Everyone with me? Yeah? Okay, so what if I go to an in that goes beyond 2 filtered sets? Bummer. Because now my estimate's not going to be as accurate. 2 times 4595 is 9,000. The actual is 2,000. And you can even see over in my executions the 9,000 number. There you go, 9,000, even though it's 2,000. So you can see everything's off because they didn't load the filtered stat. They couldn't. Interval subsumption. There was my problem. Now, I've done this a few times, and I'm not saying this always works, but sometimes, and a little bit of dynamic string execution will make your life easier, sometimes taking an in and actually writing it as a series of individual statements that you union together actually gives the optimizer the option of dealing with those statements individually. And notice I use those same values that go beyond 2 filtered sets. I run it. I see the plan looks different because it's actually doing 2 different queries. But just to show you, it did load those 2 filtered stats. And I was able to get better accurate estimates. If I run it, here's one that uses 4. Okay? And just to prove the point, 4 filtered stats were loaded as well. So my point, you can sometimes do a query rewrite. Okay? My last topic, 1 minute on this. That forced parameterization thing, which most of you shouldn't be using. Okay? But you probably are using stored procedures. Okay? So when does the estimate happen? Okay? When does the estimate happen? If they can sniff, right, then they'll use the histogram. And if they can't sniff, they use the density vector. But again, the question really is when. When does this happen? Okay? For ad hoc statements that are in simple parameterization, which is the default, it really happens every time the statement runs. Because ad hoc statements are very rare to get parameterized and saved because there's a whole bunch of rules to do that. But if somebody says, SQL Server doesn't parameterize a lot of my statements, we need forced parameterization, then SQL is going to parameterize a lot of stuff, and you could end up with parameter sniffing problems. Forced parameterization is not great for everyone. But a lot of people learn, instead of using ad hoc, use SPExecute SQL, which doesn't compile. It puts a plan in cache, which is great if the plans are stable. And the unfortunate thing, this is the biggest unfortunate thing, is that filtered objects cannot be saved with an SPExecute plan or a stored procedure-based plan. Full stop. So I've got a solution. Okay? And it's easy. This is my last demo, 1 minute. This is great because this is a short one. All right. So we've looked at our indexes. I'm not going to do that. Okay. Let's say you have a stored procedure, get customer sales. The input is the customer key. Of course, now that I'm out of time. Right. Okay, there's our customer key. And I run this with 11509, and I turn on show plan, and I see the estimate. the estimate is 7,000 and the actual is, clearly that wasn't a filtered stat. I even know so well that darn histogram that I know where that comes from those steps. It's the average of the index, which is the whole table view of the data. This isn't using the filtered stat. I know it's not using the filtered stat, and I'm telling you, it won't use the filtered stat, okay? So what can I do? If I execute with recompile, nope, not gonna do it. I create the procedure with recompile, and I execute again. Nope, I'm just cutting to the chase here. None of this stuff works, okay? You try and try and try, and you're losing your mind. You're like, something's gotta work. Well, this is where option recompile comes in. This works, okay? And if you really do wanna use a filtered object, then you will either have to change the code and put in option recompile, and I know some of you are going, I can't change the code. But check this out just to show you this. If I have option recompile, estimate actual, okay? Solve my problem, right? Now, having said that, what if you can't change the code? I have a huge number of examples of plan guides in here, okay? Here's my